I had a lot of trouble with hypersensitivity reactions and keeping the numbers straight and trying to memorize which of the disorders went with which number. In the notes is a long list of tables type hypersensitivity reaction to disorders that are associated with it. I'm not going to do that here. What I'm going to do instead is try to teach the pathogenesis of each of the types, not using their number, and at the very end, show you if you know the mechanisms and in which order they occur, you can just translate to the type number hypersensitivity reaction. So the first one we're going to talk about is IgE mast cell related. Technically basophils too, but learn it, IgE mast cell. IgE mast cells, upon first exposure to the allergen, technically an antigen, but this is what causes allergies. Exposure to the allergen the first time, you're going to get sensitization of the system. And then on re-exposure, you're going to have the immediate effects of that sensitization. Degranulation. And then, in addition, that same re-exposure is going to have the long-term sustained response by prostaglandins and leukotrienes. Now I'm dragging that out, saying all of those words because once we get into asthma and allergy pharmacology in the pulmonary section, you're going to see we're going to go after these a lot with pharm. The way this happens is we've got that CD4 positive naive T helper cell. And what's supposed to happen in nature is that the antigen presenting cell brings back an antigen of a parasite or a helminth, a worm, something that's too big to phagocytose and something that won't respond to intracellular destruction. And that would make the APC secrete interleukin-4, transforming this undifferentiated naive T helper cell into Th2. Now I say it that way because in developed countries, there's a higher incidence of allergies and asthma. Now this is conjecture, it's not proven, but it makes sense. If we have an immune system designed to fight parasites and we never see them, then it's easy to see how this could go haywire. In fact, the incidence of allergies and asthma in third world countries is less because they're actually fighting parasites and helminths. But regardless, the Th2 is going to produce interleukin-4 and interleukin-5. And yes, also interleukin-13, which are those allergy symptoms of mucus secretion and excretion. The pathology here is going to be interleukin-4 causing IgE class switching and interleukin-5 causing proliferation of mast cells and basophils, but mast cells, IgE, that's what I want you to see together. Remember, the first time you get exposed, you have the IgM reaction. It takes time to get the second wave. IgE class switching happens, and these cells are induced to proliferate. On re-exposure, it's a little different than IgG in bacteria, where the memory cell would say, oh, I recognize that, clone me, make antibodies until that bacteria goes away. With mast cells and IgE, what happens is you've got the mast cell with the big granules full of histamine. And these IgE antibodies don't circulate. What they end up doing is forcing themselves onto the mast cells and become cell receptors, the Fc portion in the cytoplasm and their antigen binding sites exposed to the extracellular space. That's a primed mast cell, such that when the allergen returns and cross-links IgE on mast cells, what you get is a massive, rapid degranulation. You didn't have that the first time because you didn't have cross-linked IgEs. But now that they are made and hyperspecific to the allergen, as soon as the allergen is exposed, it causes degranulation. And degranulation of histamine causes vasodilation and bronchoconstriction. That's anaphylaxis. The first time you're exposed to the allergen, the penicillin, you get a little rash, no big deal. Why is that? You didn't have a primed system. On re-exposure to the same penicillin, now you could have mast cells everywhere in your body primed for that penicillin, and if they all degranulate at once, you get profound vasodilation, and the patient has anaphylaxis. You give epi to help with their breathing, says the movies, but not true. Yes, it does help, but what you're going for is to increase the systemic vascular resistance so that to get them out of shock. That's what's killing them. It also happens that this degranulation, not as immediate as anaphylaxis, will induce eosinophilic chemotaxis. Now, this may not make intuitive sense since we said eosinophils are phagocytes for fungus. But it does work out in clinical practice that if you see an eosinophilia, you can think of cancers, fungus, and allergies. There's some other things in there we'll get about once we get into the clinical sciences. It's the IgE and mast cells cross-linked with the antigen stimulating the massive dilation that leads to both anaphylaxis, to eosinophil chemotaxis, which may show some eosinophils with necrosis in certain tissues, and then also the long-term effects from prostaglandins and leukotrienes. So you can imagine when we start treating these things, we've got different targets we can go after. That was IgE, mast cell mediated. The next type is two separate versions of the same thing. All of this type is an antibody is made against a target organ, and it goes to the organ to have its effect. The two variants are going to be cytotoxic antibody, which is going to be Fc dependent. Or the Fc portion is the stem, and the Fc portion was used to fight pathogens because the Fc region allowed for opsonization to increase phagocytosis, neutralization, which was helpful for viruses in particular, and activation of the complement cascade. In cytotoxic antibody dependent, the cells of an organ are tagged by antibodies. If complement uses that Fc portion, it can end up with the MAC attack complex, C5 through 9. Or it can simply increase phagocytosis or cellular killing of the self-cell. Self-cell dies. The two easiest representations of this are going to be TTP, thrombotic thrombocytopenic purpura, or hemolytic uremic syndrome, where there are antibodies against platelets and the platelets are destroyed. Or in autoimmune hemolytic anemia, that is, there's antibodies to red blood cells that cause them to lyse. Other conditions that are classic on the exam are going to be good pastures and transfusion reactions, like Rh positive. The notes have a much longer list. These are going to be disorders or diseases that are illustrative of the type. The second form of the antibody that goes to the organ and does something is the non-cytotoxic form. Which therefore must be Fc independent.